This video is to allow you to correct your homework for section 2.1.1. First thing I want to point out to you is in the methods and meanings, math notes, which is also in your toolkit, they define for you a mixed number, which is composed of a whole number with a fraction. This book series calls these types of fractions fractions greater than 1. Sometimes they're called improper fractions, but they feel that that's not completely accurate because it's nothing really actually wrong with the fraction. It's just a fraction that's greater than 1. And then they talk about the fact that how you're going to write your answer might depend on the nature of the question. So the first question is, how many tenths are there in one whole? How many hundredths are there in one whole? So what we want to do is think about one whole. If we made that into tenths, how many tenths would there be? And of course, there would be 10 tenths. And how many hundredths would there be? Well, if it's going to equal 1, there's going to be 100 hundredths. Here they want you to convert these to decimals and show your work. Now, as far as showing your work goes, I'm okay if you use a calculator, but I want to see what you put into the calculator. So for A, it would be 2 divided by 5. If you were going to do it in terms of long division, you would show it like this, 2 divided by 5. And remember, and I will go through this just so you have an example, but remember that since 5 doesn't go into 2, you would put up a 0, add a decimal point in the dividend and up in the divisor, and up in the quotient. And then we're going to add a 0 in the dividend because 2 and 0 tenths is equal to 2. Then 5 will go in 24 times, so we put a 4 up in our quotient and get our answer. So if you do it on a calculator, you're going to get 4 tenths. If you do it long division, you're going to get 4 tenths. Make sure you can do it both ways. But again, either way, make sure you're showing your work. Here I would want to see that you took 3 and divided by 8 to get the decimal. And here that you took 30 divided by 20. So remember, the fraction bar means division. So I should see that you divided the top number divided by the bottom number. For 210, Mario ordered a pizza for dinner. When it came, he ate 1/8 of the pizza. When he was getting napkins, his pet poodle ate 1/3 of the pizza. So what they want you to understand is that if we're taking 1/8 of the pizza that he ate, and we're adding 1/3 of the pizza that the poodle ate, we would need to get a common denominator or the common multiple of the denominators between 8 and 3. And that would be 24. So what we're going to do is we're going to convert these into 24s. That's why when you're drawing the model, you end up having to put 24 sections. Normally, of course, pizzas would not be divided into 24 pieces, but we needed that for our common denominator. Then you're going to show that you used your giant 1 to change 1/8 into 3 24s and shade that in. And that you used your giant 1 to change 1/3 into 24s, which would be 8 24s, and shade that in. And then write your numerical expression to show the fraction of the pizza that's left. Well, if you take one whole pizza and you subtract the combination of 1/3 and 1/8 eaten by the cat and eaten by the poodle and eaten by Mario, that numerical expression will show you what's left, and then you're going to have to figure out what's left. So what you find is, if you change it to common denominators, you end up with 13 24ths left. You should also see that in your diagram. If you take 13 and divide by 24, you'll get a decimal that is approximately 54%. So again, make sure you're showing all the work there. Here, Nicole has a machine that'll produce a number from 1 through 50. If she pushes the button, what's the probability that she's going to get a multiple of 10? Well, if it's producing numbers 1 through 50, that means your denominator will be 50. And the multiples of 10 are 10, 20, 30, 40, 50, if we're looking at those numbers. So if we count them, there's 5 of those out of 50. Show your work, show what the multiples of 10 are, and then simplify. What is the probability that you're not going to get 100? Well, in the numbers 1 through 50, none of them are 100. So 50 out of 50 or 1 whole. The probability of not getting a multiple of 4. So what I thought was easier there was to list the multiples of 4 and subtract it from 50 numbers, because there's a lot of multiples that are not, well, there's a lot of numbers that are not multiples of 4. So I listed all the multiples of 4, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, up to 50. That was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. 12 taken away from 50 means there's 38 numbers that are not multiples of 4 between 1 and 50 out of 50 numbers. Again, I want to see that you divide both top and bottom by 2 to get the simplified fraction. Probability of getting one-digit numbers. The one-digit numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 numbers out of 50. And that cannot be simplified. But again, make sure you're showing how you simplified. If you just put what I have here, that will not be quite adequate. For 212, if one half of the sections on a spinner are green and there's 14 sections, then I want to know how many are green, what is one half of 14. Again, show your work, and of course that's 7. How would you show your work, you might say? Well, 1/2 of means multiply, 14, and 14 can be written as 14 over 1. If 3/4 of the sections have stripes, and there's 24 sections, how many have stripes? So I want to see 3/4 of 24. Again, show your work. And this is the answer, but just the answer is not adequate. Here they want to know which of these will be repeating decimals, which will be terminating decimals. So if you take 2 divided by 5, you're going to get the decimal. And you can tell that that terminates because it does not go on in a repeating fashion. 7 over 45 gives you this, which is a repeating decimal, and so on. Make sure, again, you're showing what you put into your calculator, that you took 2 divided by 5 to get this decimal, 7 divided by 45 to get this, and so on. Here, you need to find the mean and median of these. I want to see for the mean that you've added the numbers in the middle. And here, if this bag has 7 green marbles, 5 blue, and 4 red, what's the probability of the given draw, meaning of picking out, in this case, a red marble? Well, there's 4 red out of 16 marbles. I want to see that, and that simplifies to 1/4. They want it as a fraction, then you should show that you got a decimal and the percent. Remember, with red or green, these and these would be considered a successful outcome. So I want to see 11 out of 16. I want to see that you showed 11 divided by 16 is what decimal and what percent. And since there are no orange, that will be pretty straightforward. Here you have to do the diamond problems. Remember, for the diamond problems, they're looking for you to figure out a pattern here. And what you should end up finding is the pattern is the 2 numbers on the side get multiplied to give you the top number, and they're added to give you the bottom. You see that same pattern here, and so on. So if the 2 numbers on the side are 3 and 4, you multiply them, you get 12. You add them, you get 7. 2 and 3, if you multiply them, you get 6. Add them, you get 5. Here you have to ask yourself, what do I multiply by 2 to give me 12? Which of course would be 6. And then 6 plus 2 would give you this. And these types of problems lead in really well to what you do with algebra down the road, where you have to figure out what 2 numbers will multiply to give you 28 and add to give you 11, and there's only one possibility, which is 4 and 7, but the 7 can be on the left or right, the 4 can be on the left or right. And then here you're going to take these numbers and you're going to write them as single fractions greater than 1. Now, we talked about that last year, but you may want a reminder. Let's say you're doing 2 and 4/15. You can think of it a couple different ways. One is that the number 2 would be 15 15s plus 15 15s, plus now we see other 4 15s. Or we talked about the shortcut last year. You can take the denominator times the whole number, add the numerator, and put that over the original denominator. So I will show you those answers, but again, make sure you have the work shown.